Okay, so normal reaction acts normal to the surface and friction acts parallel to the surface. This is settled. Now let's look at the same thing from another vantage point. Suppose there's a stick. Somebody is holding it like this and pressing it along the stick. Suppose this is a surface and this is a stick and you're pressing it along the stick. Okay, now let's see what happens. The force that you're applying on the ground is in this direction. It is along the stick. Now let's break this force into component. One of the component is along the surface and the other is perpendicular to the surface. Now what will happen? If the surface is very smooth, if it is, suppose if this is the surface, this is a smooth surface of mica and I'm pressing it along the surface. It's difficult to press it, I'm pressing it along the marker and it's difficult to press it along the marker and keep it stationary. The reason why it is so, because the force which is along the surface, it is not countered because there is no friction. Friction will act also along the surface in opposite direction. But since the surface is smooth, there is less friction, that this force goes uncountered. This force will be countered by normal reaction. So this is the force which is the stick is applying on the surface, and the force which is being applied on the stick is this. This is the normal reaction opposite to this component, and if there would have been friction, there would have been component of friction opposite to this component. So whatever force is applied on the surface offers two forces in return. One is normal reaction, the other one is friction. Now since this is a smooth surface, friction is absent, it's only normal reaction. Now if we have to draw the forces, if we have to find the force vector on this stick, we'll show one of the force which is normal reaction, which will always be there whenever there is a contact between the two surfaces and there is the two surfaces are pressing each other. Then there will always be normal reaction. So that's why in the previous problems we quickly drew one normal reaction at the contact when two surfaces are pressing each other. Now depending upon the friction, if there is friction, there would be a force opposite to the component of force which is along this surface. Otherwise this normal reaction will always be there. That's why what we do is one of the component of force we quickly draw which is perpendicular to the surface, and the other one is friction. Now if there is no friction, then this force goes unbalanced. There's a balance in vertical direction due to normal reaction, but this force goes unbalanced, so this will not stop. This will move. As you can see, if you try to keep the marker in this position, it won't stop. It would move. See, it is moving. The reason why it is moving is because if you keep a stick like this, let's think about the forces which are acting on this stick. So one of the force, quickly we will draw a normal force which is perpendicular to the surface. Now the other force is again a normal force from here, and since this surface is smooth, let's consider there's some friction on this surface, but that would be in vertical direction along the plane. If you're looking at the horizontal forces, then there is no horizontal force from at this point of contact because this is a smooth surface, and there is a horizontal force which is normal reaction. So this force, if you see, there's a net force on this stick in horizontal direction which goes unbalanced. So that's why when you keep it like this, there is a normal reaction from my palm to the marker, and that normal reaction pushes it further. That is unbalanced because there is no other counter force in horizontal direction. Right? It doesn't stop. So we're going to see this kind of situation more in a short while, whether a stick or a body will be in equilibrium or not, depending upon where there is balanced force or unbalanced force. So now what we have done, studied 5 common kind of forces, contact force and field force, that we have to deal with. And we are going to study equilibrium of body in a short while. Before that, we're going to study this. And this is called free body diagram. FBD.